So in this video, I'm going to be doing an introduction to projectile motion. For that purpose, I'm going to be using this simulation, which shows a cannon here, and this cannon shoots pumpkins. And so let's shoot one and see what happens. So we shot a pumpkin there, and then you see there is this trajectory here. This is a parabolic trajectory, and this is a motion diagram of this pumpkin falling. So this is an example of projectile motion. So let's just see what else we can do. We can change a few things here. We can change the angle, right? So now that's 30 degrees. Let's shoot again and see what happens. Now it lands at a different place, right? So the horizontal distance from just here all the way here, or from here all the way here, that is called the range of the projectile. This point where it reaches the maximum height, this that point, that is the maximum height. So now let's look at this. Let's keep changing the angle here and see what happens. So if we do this, then it goes out of the screen for a little bit, but it falls short a little bit. So there is an optimum angle here that will give you the maximum range. So what I want to do now is I want to show, I'm going to clear all this path, and I want to show a little bit of the vector velocity and the acceleration of projectile motion. The key to understanding projectile motion is to understand that there are two coordinates. There's the x-coordinate and the motion in the x-axis, in the horizontal axis, and the y-coordinate and the motion in the vertical axis. So let's show the velocity vector, right? Well, let's show first a trajectory here. That's a trajectory. Let's just increase this angle a little bit. And 45 degrees. So that's your trajectory. That's a parabolic motion. This is the range here where it lands. This is the maximum height. So now I want to show the velocity vector. Let's show the velocity vector. And what you see is the velocity vector changes, but it's always tangent to the path. It is always tangent. So let's do it in slow motion and see that again. So you can see that green vector that is decreasing, and then it is always tangent to the path. So let's show the components of the velocity vector, and let's do that in slow motion. So those are the components here. And what I want you to notice is that the horizontal component is never changing. What does that tell you? Let's try it again. So you can see the horizontal component always remains the same. So the velocity in the x-axis doesn't change. So that means there's no acceleration in the x-axis. Now look at the velocity, the component of the velocity in the vertical axis, in the y-axis. It decreases, reverses direction, and now it increases in the negative direction. So that means there is acceleration in the vertical axis. What is that acceleration? Well, as you would expect, it has to be gravity. So the acceleration is gravity. So let's plot that acceleration and see. So that is this yellow vector here, and it's always the same. Gravity is always pointing down. So the key concept to remember is that there's two motions. There's a motion in the x-axis and a motion in the y-axis. The motion in the x-axis has constant velocity. There's no acceleration in the x-axis. The motion in the y-axis has acceleration. It's gravity. It's a free fall motion in the y-axis. And so the path of the object is going to be a parabolic path. The distance where it lands is called the range. This is the maximum speed. This is the maximum height that it can reach, the maximum speed. At this point, the velocity is horizontal, right? And there is no velocity in the vertical direction. You can see that. Let's try that and see what happens at that point when it reaches the maximum right there. Well, I went. Let's try it again and see if I can catch that point. Let's see. Stop. Right there, almost there. So you can see there is no, I'm not gonna show the acceleration vector. There's no component for the vertical direction of the velocity. At this point, it's all horizontal direction that never changes. And you can control a few things in the projectile motion. You can control the angle and the initial speed, and by doing that you can control where the object is going to land. So this has been a quick introduction to the main ideas of projectile motion. So thank you.